Example 3 is our first definite integral that we're going to take a look at, where we're going to be using U-substitution. Now, ultimately, there's two ways to handle the limits of integration on this one. I'm going to be showing you one of those techniques today. So first, let's take a look at my integral. X squared times x cubed minus 4 in that quantity to the 2/3 power. So that's my integrand. So looking for a composition here, I see x cubed minus 4 raised to the 2/3 power. So I'm going to come over to the side here, and I'm going to let u equal x cubed minus 4. I'm actually going to rewrite that 4 like this. Okay, good. So let's go ahead and take the derivative of that with respect to x. So du dx is 3x squared. Now, unlike the last couple of examples we've looked at, right, here the derivative has an x squared in it, and I have an x squared as a part of my integrand, right? So I won't have to solve for x like I did in the last couple of examples, okay? So instead, I'm just going to do what I normally do. I'm going to multiply the dx over 3x squared dx, and now I'm going to try to get x squared dx by itself, right? Because that's in my integrand. And so in order to get that, I'm going to divide by 3. So I get 1/3 of du is equal to x squared dx. And so now I can go ahead and substitute in my integral. So that part, you know, the actual integrand here is actually easier to deal with than the first two examples. Okay, so let's go ahead and do my U-substitution, and right away you will notice something that is amiss here, right? My limits of integration here are 1 and 3, so that's not a problem in itself, right? X cubed minus 4 is what u is equal to. Whoops, forgot to highlight that. Okay, so I'll write u to the 2/3 power, so no issues with any of that so far. Okay, so u to the 2/3 power times, and then x squared dx gets substituted for 1/3 du. Now again, no actual issues with anything that I have here in my integral, okay, except these limits of integration you have to be careful about, right? These are limits of integration in terms of the original variable for this integral, which is x, right? This is an x value. X is supposed to equal 3. X is supposed to equal 1. So when I go ahead and do a U-substitution, right, I'm dealing with a completely different variable than the initial question did. So I cannot write 3 and 1 here as my limits of integration. Now, there again, I mentioned this earlier, there's two ways to handle this. The first way is just to do this integral, right, get your answer and substitute the u value, which is x cubed minus 4 back in, and then do the definite integral part at the very end. I'm going to show you another way of doing it, right, which is why part of this section is called complete U-substitution. I'm going to substitute everything to be in terms of u, including these limits of integration 1 and 3. So I'm going to come to the side here where I know what u equals. I have a formula for it, and I'm going to plug my x values into that formula. U is equal to 3 to the 3rd power minus 4. So 3 cubed, 27, minus 4 is 23. So when x was 3, u was 23. And I'll do the same thing when x is equal to 1. So u equals 1 cubed minus 4. When x is equal to 1, u is going to be equal to negative 3. So let me substitute in these values of x, 1 and 3, in with their corresponding u values, negative 3 and 23. Okay, so another example of a complete U-substitution, right? We are replacing everything, including limits of integration, in terms of u, and now we can go ahead and evaluate. So I'm going to bring the 1/3 out, and this integral is going to be, let's see, from negative 3 to 23 of u to the 2/3 du. So just rewriting my integral with that constant pulled out, okay? And now let's go ahead and do the antiderivative. So this is going to be 1/3 factored out again, right? And then this will be what? 5/2 u to the, whoops, did I say 5/2? Sorry, that's definitely wrong. What am I looking at? Let's see, if I add 1 to this exponent, that should be 5/3, right? Take the reciprocal of that, it should be 3/5 u to the 5/3, and this is from -3 to 23. Okay, and now, right, you would go ahead and plug 23 into this, right, and then -3 into this and calculate it, right? So this is doing, second part of the fundamental theorem of calculus, right? This part we're familiar with. Now, these particular numbers don't work out very nicely, right? 23 to the 5/3, -3 to the 5/3, right? So I'll say at this point, let's call it a calculator question. So why don't you go ahead and pause the video, try typing this in on your calculator and seeing if you can do this appropriately. And the correct answer you should get is, rounded to 3 decimal places, 38.451. Okay.